Hello everybody. We're going to tackle the subject of condition monitoring today. Now, I've often heard a phrase, if it ain't broke, don't fix it. Well, that's fine until it does break, and then you have got to fix it. So that can be quite a costly thing. It can be quite an annoying thing. So today we're going to tackle that subject, and I'm with Mr. Dave Breckell of Omron, who's going to talk about how they help customers to deal with those issues. So first things first, Dave, why should engineering plants look into condition monitoring?
Well, Andrew, there's a number of reasons why you might want to look into condition monitoring, but probably the foremost one is the sheer cost of unplanned downtime. Over 89% of British manufacturers report having had unplanned downtime in the last 2 years, and on average the cost of that is over £5,120.
Right.
I mean, that can vary a lot. You know, obviously a small SME, it might be less. If you were to stop an assembly line at a car plant, it might be £5,000 a minute. But there's a sizable cost involved when you don't plan downtime. Also, the average time for that downtime is about 19.2 hours. So again, it's a lot of lost production. When we've looked into this downtime, typically 44% of those instances are caused by failure of machinery. So whether that's an electric motor running a fan, pump, conveyors, or components within the panel. In addition to those costs, you've then also got to look at something along the lines of reputational damage if your product's not at 100%, because obviously if your production line is running suboptimal, you might be producing a slightly inferior product, or you have extra scrappage. The second reason for us is OEE and lifespan of the machinery. If you put in a production line, a packaging machine, there's a considerable cost involved in doing that. If we can monitor it and actually pick up failures before they happen, we can quite often prevent A, downtime, B, costly repairs, and C, it might be a case of if you know there's an issue with the machine, you can reduce the throughput. You can run it at a lower speed for a period of time until you can schedule maintenance.
Right.
The third reason, which is equally important really for me, is the safety aspect of it. If you have an issue with a fan or a pump or a motor on a critical system, or for example a power supply fails and takes out your safety control, or God forbid, if you have issues with over voltage and you have a fire within a panel, these can all have direct impacts on the safety of your production line and your processes.
Yeah, I totally get it. Could you explain the differences between traditional manufacturing and smart manufacturing?
Yeah, certainly. I mean, traditionally, we were reactive, weren't we? So we waited, something broke, and we fixed it. And that brings all the costs and stuff that we've just discussed. Many years ago, we started to move towards what's called preventative maintenance, and that's your more time-based traditional strategy. So, if we looked at something like an electric motor, it might be taken out of service every 2 years, and then a skilled maintenance technician will isolate it, maybe test the insulation resistance on it, check the bearings, complete a checklist, and put it back into production.
Yeah.
That's quite a valid strategy, but it's quite time-consuming. It needs a skilled person to go and do it, and it also doesn't take into account how much the machine's been used. Has that motor ran for 2 years? Has it ran for 2 minutes or 2 weeks? So you may end up doing maintenance you don't need to do. Now we look at what we call predictive maintenance, and that's essentially where we're taking real-time data from the panel, from the components, from the motor, and we can actually judge when maintenance needs to be done. We can automate the process, and we can also pick up on things far, far earlier. Rather than a motor essentially failing, we can pick up on vibration and noise long before it becomes a problem. So again, that can reduce maintenance and it can increase longevity of the components.
You're right.
The last thing just to very quickly mention is you'll also hear then smart maintenance, which is taking that data and then trending it over a longer period of time to get better insights, and maybe linking it to your MES or ERP systems so that you can actually schedule production around maintenance and usage of machines, etc.
Okay, so clearly this is a big subject. This is a major subject. So who should be using condition monitoring, and are there engineering plants out there that aren't using condition monitoring?
I think virtually everybody should be looking at using condition monitoring now. There are sometimes a little bit of reticence in the market for a number of reasons, but they're all unfounded, if you want my honest opinion. What a lot of people are concerned about is firstly the investment to actually put in a condition monitoring system, because there's a perception that the typical factory has up to 20,000 data points. Well, where do you start? How much stuff do you monitor? Suddenly it becomes a very big capex investment. There are often a lot of concerns in terms of, will it change my existing control system? If I'm retrofitting something in there, could that cause problems with production? People are often concerned about data. If if now I'm having to connect all this data to the cloud, is there going to be an IT security risk? Is it going to slow down my network? Sometimes it can be something as simple as just trying to get an IP address from the IT department. It can be a fight on its own. And then the other two sort of things that sometimes people put as a concern are, do we have the staff in order to maintain and create a system like that? And the cost involved, not just for the initial outlay, but then for subscriptions. You know, am I going to have to pay for every motor or every panel that I'm monitoring over time? All these things can actually be negated. So at Omron, we use essentially a technology called edge computing, which I can explain to you. And this does away with a lot of these issues.
Okay. So that's quite interesting, because you mentioned things like the skills shortage, and the fear, of course, of investment.
Yeah.
And will it necessarily? So it's quite a thing. Let's look at specifically what Omron offer to help their customers achieve this. Could you give us an overview?
Yeah, certainly. As I mentioned, you know, a lot of the systems on the market have initially been cloud-based. So you've had a lot of data points all going out into the web, and then they'd go on a cloud server. It would do all the monitoring, the OEE. Omron's philosophy is we do it locally on the machine, what we call edge computing. So essentially, if you're monitoring an electric motor, like we said, you could have a motor monitor which would be in panel, so your data stays in your machine, and we can monitor things like vibration, temperature. We can use current analysis to check the bearings. We can check the load attached to it. We can do even things like insulation resistance on the fly. And this can all be done automatically, and it's done within your machine. When we're looking at something in panel, you know, we can do things like we have some very advanced temperature monitoring products. We have intelligence in even the simplest component like a power supply. You know, if the power supply goes down, it takes down everything downstream of it. We have IoT sort of condition monitoring built into those, so we can see the usage, the current, the lifespan, the temperature it's running at.
Okay.
And it's even built into things like our inverter drives now. We have condition monitoring in there where we can monitor the IGBT packs, the capacitors, etc. So with Omron, it's all done locally in the machine. You know, you can start small and then you can essentially scale it up. As I mentioned, what we would probably do in a typical application is we'd say pick the three most important motors for you in terms of causing issues with downtime or delivery, and then we can scale it right the way up to a full system. So you can start off with a small OPEX investment and you can scale it up to whatever you need.
Okay, that's quite interesting. Can we see some of these things in action now?
Yes, of course. I'd be very happy to show you. Well, what we have here are our K6 motor monitoring products. So these are edge devices, as we discussed before. So all of the control and justification is done in the device itself. So this sits inside the panel. We have 3 units here that I can show you today. We have the first unit here is doing essentially what we call current analysis. So that's checking to see the condition of the load connected to it. We can look at the bearings, for example, you know, see if there's bearing scratch. We have another unit we don't have here today that does insulation resistance as well. The unit in the middle here is a more traditional vibration and temperature, which is obviously one of the first indicators of a problem with the motor. And then on the end here, we also have a temperature one designed for the panel. So we'll go through this in a moment, but this essentially lets you monitor a wide range of different components at the same time within the machine. Because it's edge computing, it's a very simple way to wire it up. You can simply have a set of output contacts, just going to say a tower light or an issue. There's an indicator on the front there, which will tell you if it's in a pre-fault condition and then a fault, for example. But they're all linked together on Ethernet IP, which is a very open network used by many manufacturers, and we can take that data into an EAP system, an MES system, where we can trend that data over time, and we have free software that we can give you as well. So to show really this stuff in action, you know, if I start the motor up, what we have on here is an unbalanced load. So as it starts to speed up, you can see the vibration on the front of it there. Over time, this will start to cause an issue. We have an amber, so that could be a warning. And then eventually, once this run for a period of time, it'll go red to indicate a fault condition, which you could then use to stop the machine.
Right.
The first unit on there is actually doing the current analysis. So again, you know, we can see in real time that's the current there, and we can take that data out so we can analyze how the bearing's behaving. You can see there now it's just errored for us.
Right, understood.
The third unit is actually the temperature within the panel. Now, one of the big issues we have with components is obviously ambient temperature in a panel. For every 10 degrees you have above the operating range of a component, say it might be minus 10 to 40 degrees, you're approximately half its lifespan. So maintaining a correct temperature within a panel is very, very important for the longevity.
Right.
One of the issues they do have with temperature in a panel, though, is that typically it's done using a thermostat. You know, if we were to look in this panel here, you know, we have a thermostat on the door there, but it's a relatively blunt instrument because it's only measuring the ambient temperature of the whole panel. Now, what is a safe condition in terms of temperature for a power supply might be different to what you would want to operate on as a solid-state resistor or a drive. What we have using the K6 family is we have a series of thermal cameras, and these can be basically mounted within the door, so you can mount them across a wide range of areas, so you can put 8 of them together for a really large panel. And rather than measuring an overall average temperature, what it actually does here is it splits it into 16 segments, and each of these segments you can have a spot temperature for each individual component. So looking on here, I can see the temperature for each area within the panel. We can overlay a photograph on it, so you can actually see, so it makes a bit more sense when you're looking at it. You can see that's the power supply, that's the drive. But we can also set alarms for individual components. So we can go into the threshold setting there, and we can set an alarm output for a warning, and then an alarm output for an over temperature. So we can actually set specific temperatures for every component in the panel, and it doesn't just wait for it to reach that temperature, it starts to trend it. So if it's starting to rise at 5 or 10 degrees and approaching its maximum temperature, it can give you an alert before it gets there. And finally, I'd like to show you our S8 VKX power supply. Okay. The S8 VKX is an intelligent power supply. As we probably mentioned earlier, if you lose the power supply, you lose everything downstream of it. So it's vitally important that you keep it running. What we have within this unit is essentially an Ethernet port. So the Ethernet port lets us get some standard data on the lifetime of the power supply, its temperature, its lifespan, the load connected to it. If I close the panel just for a moment here, you can see some of the information we can get out of it. So in real time, we can see the output voltage, the current, peak current. For us, really from a condition monitoring point of view, we can see the total runtime and percentage until replacement. So typically a power supply would have a 15-year lifespan. This will increment itself down, but it also takes into account the usage of it and the temperature it's running at. So we mentioned before when we looked at the thermal camera, that extra 10 degrees above the operating time can actually halve its lifespan. Well, if you were to overheat this for too long a period, it will start to change its lifespan curve down as well. So it's got a series of algorithms built in, lets you do that. Obviously it will keep working, but this is really important because when a power supply fails, they tend not just to fail immediately. What will happen is the capacitors break down, and you'll get voltage fluctuations, and that can cause issues with comms and all sorts of stuff. So the simple addition of an intelligent power supply can give you a lot better reliability.
That's fantastic. Thank you very much.
No problem.
Okay, so thank you, Dave. I appreciate the demos that we've had there. Now, if we go back to that phrase, if it ain't broke, don't fix it. Now, we touched on that people have got fears about dealing with that issue, but can we just go back to where do they start? What's the first step for them?
Well, for me, the key is start small and scale it. So typically, as a starting point, I would look at something like electric motors. That's one of the common causes of failure. I would pick the 3 motors that are offering the biggest risk to your business, whether it's because of the critical part of the process, could even just be the long lead time in terms of getting a replacement part. And I would fit something like a condition monitoring system onto it. I would stress that the beauty of the Omron solution is that it is essentially a retrofit. You're not taking code from the existing PLCs, you're not having to modify any of your existing plant, so there's no risk to you going in and messing with something that might have been there for 15 or 20 years. You can start with those 3 or 4 data points, we can take that into some monitoring, and it doesn't have to be a high-end system. We can simply just have it as an alarm output. You could have a tower light, for example, with an alert and then a stop. Or we can supply quite a lot of solutions where we can trend and monitor it over time. But yeah, start small, doesn't involve modifying anything, it's not a big CapEx investment. You can dip your toe in the water and then we can scale it up to be a far more comprehensive system.
Okay, I understand that. But you've also mentioned as well that Omron has a lot to offer in terms of knowledge base.
Yeah, I would say that probably the first port of call is that we have a smart monitoring website. There's a lot of white papers, some of them industry specific, but they give a lot of guidance on how you can implement a condition monitoring system. We have a lot of technical training on there as well as the traditional product stuff. Also, we have a wide network of field application engineers and tech support people here, so we're more than happy to come and have a chat. And we have a strategic partner network of distributors as well that are trained up on the product.
Yeah, excellent. That's brilliant. Well, look, thank you very much, Dave. This is clearly an important subject. Clearly, there are very, very strong reasons to look into this. It's even stronger because downtime is only a problem when you actually have downtime. But obviously you don't want it. So if there are steps to prevent that, then it's logical to dig deeper into the subject. Now, of course, we'll provide links across to all the relevant Omron specialities here, but there really is a strong knowledge base. it's very traditional, or it's a suggested tradition in English manufacturing that if it ain't broke, don't fix it. But clearly, none of us can afford the downtime or the kind of figures that are being discussed. So it makes sense to look into this. We've only skimmed the surface today. There's much, much more to find out. So if you are interested, contact Dave and the team at Omron, and I'm sure they'll be happy to answer your questions. Thanks ever so much for watching. Thank you, Dave, for your time, and we look forward to seeing you on the next video.